Welcome to Chapter 32. I know I said that Chapter 31 was my favorite chapter in the whole book, but I think Chapter 32 really is my favorite. Chapter 32 is on surfacing. Surfacing is a lot of fun because it's like working with solids, but under the hood. You have to get your hands a little bit dirty when you're working with surfaces. Solids are a lot of automation and things that are done for you automatically, but surfaces allow you to take something apart and do it piece by piece manually. I've got a couple examples of things that I've done in surfaces, and I'll show these to you, but the reason you use surfaces is usually because you need to do a 3D shape, but you need to make it face by face. You can't make the entire thing all in one shot. For example, a shape like this watering can. How was this created? This is kind of a complicated shape. Most of it was created in a single surface. Let's roll it back and see what's going on. First, we got a lot of planes, but we've also got a curve. Let's show this. This curve is the upper edge of the watering can, and we can create this from two separate sketches. This curve was projected straight up, and this curve was projected straight across, and where they intersect in space is this curve called the projected curve. Created a loft surface. So you can see that the curve is the top edge, and the loft uses a bunch of sketches. Now, one of the things that you want to keep in mind when you're creating surfaces is that it's a good idea to create a surface that's bigger than you need. Notice that at the bottom, we didn't try to produce the flat bottom all in one shot with the rest of the shape because you probably can't get the flat bottom and this top curve all at the same time. So what I did was I just created this extra bit and then cut it off later. So now I've got the basic shape of the watering can, and it's symmetrical, so I can mirror it. Now, in SolidWorks, you can't mirror curves, which is a really weird thing. So what we wind up doing is we will create a surface from a curve and then mirror the surface, and then you've got an edge on the other side that you can use kind of like that curve. Had to close up the handle a little bit because I wanted a little bit of a gap over here as well. Then we trimmed this out to give it a little curvature in there. A planar surface, probably for the bottom. So that's the planar surface. And then we knit it all together. Now, knit is a way of merging surfaces into a single body in the same way that you would use a Boolean tool or the merge result option in a solid feature. Surface features, by their very nature, do not automatically merge with one another. So every time you make a new feature, it's generally a new body. Put a fillet on it. You can put fillets on surface bodies. And from here, we use the thicken command to make this into a solid. Notice if I, let's try to see both ends of the tree at once, roll this up, and I have surface bodies, one single surface body. Roll it down, and I've got no surface bodies, but now I have a solid body, and it's that thicken feature. Okay, and then I put on a fillet to fillet the thickness edge of the part all the way around. So that's one use of surfacing. Let's take a look at another one. This is a mouse that I created. We use this one in the multi-bodies chapter. Let's roll it back, and you notice I've got a folder here that keeps all of my surfacing work in it, allow me to keep a fairly compact feature tree while I'm working in solids. So let's roll this back again within the surfaces folder, and we see that the first surface is a loft created from 3 sketches. Now, a loft is usually an interpolation between multiple curves. So what Solidworks is doing is interpolating between this edge and this edge, but using this center spline as a guide curve. If we edit the feature, one of the things that we can do is use the mesh preview, and we can show a different density on the mesh preview. What this shows is the underlying structure of this feature, and it really demonstrates better than anything that when any NURBS modeler creates a surface, that surface really wants to be 4-sided. It's like if you were to weave, say, a bed sheet. A bed sheet wants to be 4-sided because it has threads in 2 directions. It has threads in this direction, and it has threads in this direction. And that's what this mesh represents. Threads in 2 directions. And just by nature of having threads in 2 directions, you come up with a 4-sided patch. So when I wanted to create a mouse, you're not just going to create this shape directly. The way you want to start out is you want to get this 3D shape. You want to get this shape of the face that you need, but you're probably going to want to start with a 4-sided patch of some sort. And from here, we can trim this out to the shape that we need it. The way we got to this in particular was you saw the surface loft, and then we created another surface loft. This one goes around the outside, uses that trimmed edge as one of the sides, and then uses a number of smaller sketches to help get that shape. And then we lofted a closed loop. And then from there, we trimmed out one surface with another and trimmed out the whole. Then we added another feature in the whole. Now this surface fill is a special type of surface. In here, I sketched the contour that I wanted to fill this hole with. You'll notice that this is kind of breaking my rule that I'm talking about of creating a 4-sided surface, but it's not really. Let's take a look at how the surface fill is created. And what SolidWorks is able to do with this tool behind the scenes is it's actually creating a 4-sided surface, but it's trimming it to the boundary that I give it. SolidWorks is just not showing the extra trimmed part of the 4-sided surface, but you can see from the mesh that it's just an underlying 4-sided surface. Now, in an introduction, I should probably go through some of the tools that are available to you. Extruded surfaces, a lot of these tools are going to be the same as solids. We got an extruded surface, a revolved surface, swept surface, lofted surface. The boundary surface is going to be the most useful because it's like a loft, but it treats the first and second direction equally. So in a loft, you have a profile and a guide curve. In the boundary surface, you just have direction 1 curves and direction 2 curves. And as we get into this in the chapter, you'll see more about this. The boundary surface is going to be the meat and potatoes of what you want to use when you're working with surfaces in SolidWorks. The filled surface is kind of the magic carpet. It's the free form is something you probably won't use that frequently, but it allows you to take an existing surface and tweak it some. Planar surface speaks for itself. Offset surface as well. A ruled surface is something you'll use in special situations, but you'll use it fairly frequently. In particular, if you have to create a drafted face around something, you'll use a ruled surface. A ruled surface is a surface that in one direction can have curvature, but in the other direction always has a straight line. A flattened surface, if you need to manufacture, say, a sticker or a patch or something, this is for something, the type of shapes that you wouldn't do with sheet metal. You can do fillets as well. Then we have other types of functions like a delete face, which will remove a face from a body. Replace a face means that for solids or surfaces, you can replace one surface with another, and it will either extend or trim the surrounding surfaces. You can manually extend open edges of surfaces if you want to, or you can use other bodies or entities to trim a surface. You can use a sketch, a plane, or another surface to trim a surface. Untrim a surface means that if you were to take, let's untrim a surface. Remember how this top surface was created from a four-sided patch, but now it's kind of a random shape. And if I want to untrim the surface, I'll select it, and Solidworks is going to show me a four-sided patch. There are a lot of things that you can do with surfaces in Solidworks. It may open up a whole new world for you when it comes to modeling. Surfaces are not just about crazy shapes. You can also create mathematical shapes with surfaces, and you can also do some functions that you need in machine design type work with surfaces. And you'll see some examples of all of this in this chapter.